All right, so let's review this a little bit, because this is kind of where it gets a little bit tricky. Because you never really know. Most of the time when you're doing a lab or you're reading your book or whatever, you come across a chemical name, you don't know off the top of your head if it is an ionic compound or a covalent compound. So let's just say that we're going along and we have something called calcium chloride. All right, we want to write the formula for that. So first thing that we have to do is we have to figure out whether or not it's an ionic compound or a molecular compound. Just looking at that name, how do you decide? Well, the first thing you ask yourself, does it contain prefixes? Are there any prefixes in this compound? Well, no, there's not. So if there are no prefixes, what kind of a compound is this? It would have to be ionic. So an ionic compound is not one that uses prefixes. Well, what if the answer is yes? What if we have, what if we have carbon tetrachloride? If we have carbon tetrachloride, wait a minute, there's a prefix, so that must be a molecular compound or a covalent compound. Those are the same things. Okay, so the first question that you have to ask yourself, are there prefixes? If there are prefixes, it is a molecular compound. If there are not prefixes, it is an ionic compound. In the case of a molecular compound, this one is pretty simple. If we want to write the formula for this, then all we have to do is convert the prefixes. Okay, so we have carbon and we have chlorine. There is no prefix here, so there's one carbon. We have 4 chlorines here, so it's CCl4. Okay, so molecular compounds are pretty straightforward. All we have to do is take the prefixes, convert them into subscripts, and we're done. Now in an ionic, okay, over here we do not have prefixes. So in an ionic compound, the first thing that we have to do, let's write the symbols. Let's start with that. So we have calcium, and we have chlorine. So the next thing that we have to do is how many of each do we need? We don't know because we don't have the prefixes. But we do know that we can figure out how many we need if we figure out the charge on each ion. Let's do a different color for everyone. All right, so if we write the symbols, we determine the charge as our next step. Okay, so the way to do that, remember, is on our periodic table. We have calcium over here in the second column, so it has a 2 positive charge. We have chlorine over here in the halogen column, so it has a 1 negative charge. Once we determine the charges, then we just balance it. So we want to balance those charges. Okay. So if we have a 2 positive here and a 1 negative here, we need another 1 negative. So our formula for calcium chloride would be CaCl2. Now what if we don't know those? What if we have, let's see, what if we have copper 1, let's make this hard. What if we have copper 1 nitrate? Okay, first thing that we would have to do is write the symbols. Copper is Cu, but where is copper? Copper is in this middle part. This is a transition element. So we don't know the charge just yet. So we have copper as Cu, and we have nitrate as NO3. This is one of our polyatomics. Here's a couple things here. Symbols. Is it a polyatomic? Okay, pay attention to that. Because if we have nitrate, we have to make sure that we write NO3. So the charge then We might have to determine whether or not this is a transition. Okay, if it is, how do we determine the charge? Well, if it's a transition, it should have this written there. Okay, it should have a Roman numeral that tells you what? Remember, this Roman numeral tells us the charge on the copper. So if we have a Roman numeral of 1 with our copper, we have a 1 positive charge on our copper. Nitrate, we know, is 1 negative. So to write the formula for copper 1 nitrate, we have CuNO3. So writing chemical formulas, here's essentially the steps. If you have an unknown compound, doesn't have prefixes. If it does, it's molecular, and you just use the subscripts. If it does not have prefixes, it's an ionic. You have to write the symbols, pay attention to whether or not it's a polyatomic in that particular case, and then determine the charge. Determine the charge by looking at the periodic table or looking to see if it's a transition element. Okay? And then once you have those charges, you can balance the charges and write the symbols and the subscripts based on those charges. Okay, well, writing chemical formulas is a pretty straightforward thing. There's not a lot of steps to it. The naming compounds has several different paths that it can take. So, for example, if we have these two compounds and we want to name them, the first thing that we have to do is we have to decide what is that compound made of. So, part 1, what is the compound made of? All right, now there's basically two options that we can go with that. All right, so is it a metal and a nonmetal? All right. Metal and nonmetal. Or is it two nonmetals? All right. Depending on what it is made of, that's going to determine what it is exactly that we're going to do to name it. So let's start with this first one. This first one has potassium and it has bromine. And if we bring our periodic table back, we can look over here and we can see that potassium is on the left of this stair-step line and bromine is on the right. So this is a metal and a nonmetal, which means this is an ionic compound. When we talk about an ionic compound, all we have to do really is name the ion. So the second step in that, let's name it. Well, okay, K is potassium. Br is bromine. And we know, however, remember, that our negative ion is going to change the ending to IDE. So we have potassium bromide. Now, what if we have this one? What if we have copper and bromine? All right, this one is a little bit different. Our potassium bromide, we're done. But if we have copper bromide, okay, we have copper, same thing, we're going to change the ending to IDE. But what we need to look at here is the cation, is it a transition? If it is a transition element, remember that means that we can have more than one charge on our cation. So is it a transition? Well, if it's no, then we're done. However, if the answer to that is yes, what do we have to do? We have copper bromide, and to distinguish that, remember we have to come back and look at these charges. Bromine is here on our periodic table. Bromine is one of the halogens. So the halogens have a -1 charge. And since there are two of them, we have 2 total negatives on our bromine, which means that copper must have a 2 positive charge. So we have to distinguish our copper as copper 2. So if this is a transition element, If the answer is if the answer is yes, we have to write the charge as a Roman numeral. Oops. Numeral. Okay. So, if this is a transition element, okay, potassium is not, but copper is. If it's a transition element, we have to go back and add in that Roman numeral. Now, if we look at this one, if we look at that one, we have two nonmetals. We have carbon and we have hydrogen. So carbon is here on our periodic table, and hydrogen is, remember, this one over here, but it's still a nonmetal. So we do have two nonmetals in our compound. So the first step, we have to name each element. Notice we don't call them ions because they're not gaining or losing electrons. So we have carbon and hydrogen. Same thing as we did over here, we're going to call it hydride. We'll change that ending to IDE. Now remember, in molecular compounds, remember when we talk about those covalents, we have to indicate how many of each atoms there are with prefixes. So after we name the element, the next thing we do is we, what would we call it, convert. Do we convert it? We converted in the last one. We can convert the subscript to a prefix. Okay. So the subscript is this number down below. So we have two carbons. And if we remember from our prefix list over here, our prefix list 2 is di. So we would have di-carbon. And we have 6 hydrogen. 6 is hexa. So we have dicarbon hexahydride. Now another question that we have to ask, we can't really just stop there because remember, if we have, let's just say we have NO. If we have those two. Remember, if we have those two, we have nitrogen and we have oxygen. We have nitrogen oxide. We have a nitrogen and an oxide. Each one of these, we have one of each. So we would have mono nitrogen, monoxide. But remember, another question that we ask here is mono the first prefix? All right, so remember that is important. So if mono is our first prefix in our first element, we would cross that out. So what we would have is nitrogen monoxide. All right, so if mono is the first prefix, if it's no, then we're done. Okay. If the answer is yes, then we delete it. Okay. So if we have mono in our first element, mono nitrogen, we just write nitrogen. So when we're naming compounds, first step we go through, what is the compound made of? Is it two nonmetals or is it a metal and a nonmetal? That's going to determine what types of names we give these particular compounds. Okay, this indicates that it's an ionic, so we have to name the ion, determine whether it's a transition, and then indicate the charge with a Roman numeral if it is. For two nonmetals, we're going to convert those subscripts into prefixes and write them with those.